Hi friends, welcome to my channel. Today I am going to explain you how to control our glowy LED with analog value. In my last tutorials, I explained you how to glow a LED with digital values. So what is analog value? Analog value is a value where where the current to LED is received in float data type. What is float data type? Float data type is a data type which has decimal points or fractions, just like 1.3, 0.5, 0.58, etc. So, what is the difference between analog value and digital value? Analog value sends the current in decimal points like 1.3, 2.3, 2.5, 2.58, etc. Digital value either gives in 0 volts or 5 volts. So if we declare a pin as high for digital, in case of digital, then it will give output as 5 volts. If we declare the pin as high in analog value, in the same way it gives 5 volts. But if you want to control the analog value with the help of Arduino UNO, then you need to write a for loop. So this will be further explained when I am explaining the code. So just like last time, we need to glow a LED. So we need a Arduino UNO, breadboard, couple of wires, a 1 K resistor and a LED. In my last tutorial, I explained even about the LED. The last tutorial link is given in the description. So, in the same way, we need to connect the 5 volts of the Arduino to the positive of breadboard, negative to the ground of Arduino, place the LED perfectly in the breadboard and connect the pin number 3, which is a PWM pin used to control LEDs. So connect the positive terminal of the LED to pin number 3 of Arduino. Make sure that you connect it properly or else your LED may fuse. Connect the 1 K resistor to the ground of the LED, and at the end you need to connect the 1 K resistor to the breadboard's ground, which is connected to Arduino's ground. Make sure that these connections are proper. So I will be uploading the code, then you can see. So this is the code we need for the glowing of an LED. Constant int LED equal to 3. Over here, LED is a variable and constant declares it as constant, means LED equal to 3, it is declared as 3, and int is a data type. 3 is the pin number 3 of our Arduino, which is a PWM pin. In void setup function, we need to write pin mode is another function which declares the Arduino's pin as given pin. So LED underscore AO is pin number 3, and this pin mode function declares pin number 3 as output. We can write so. Now we declare this at out. In the void loop function, we need to write for int brightness equals to 1 colon brightness should be less than or equal to 255 brightness plus plus. So, to make this systematic, we may add some spaces for better understanding. And now, I told in the starting of my video that for is another type of loop. For loop is used, or while loop can be used. For is most suitable for over here. Int is the same data type which I declared over here. It has certain brightness equals to 1. We declared the brightness as another variable by int data type, and the value of brightness is equal to 1. And now we declared brightness, we added a colon so that this whole sentence is end. And we started a new sentence known as brightness should be less than or equal to 255. 255 is a value over here. And it should be less than or equal to means it could be 255 or less than 255, which is 1, 200, even 254, and 255 is also counted. Again, we added a colon so that the sentences end. Now, brightness should plus plus. So brightness is a variable which we declared over here, and plus plus means it's gradually increase the value till it's assigned. The initial value is 1 and the final value is 255. So it gradually increases from 1, 2, 3, 4, 5 and so on till 255. And when it increments, it writes analogically because we are giving out analog output. In my LED AO, over here we declared as pin number 3 of Arduino. In the same way, the brightness is a variable which we declared over here, and it gradually increases and stores the value and interprets over here. Delay equals to 10 milliseconds. So in the same way, I wrote here over here we have written 255, so brightness should be 255 and brightness should be less than 255, and I add more spaces for better understanding. So now I added just like plus plus, I wrote over here in the same way minus minus. It gradually decreases from 255 to 0. So in the same way, I wrote analog write underscore LED underscore AO brightness, and again delay is 10 milliseconds. Now let's upload the code. Hooray, the code is uploaded. Now you can see that the LED glows and dims. In my last tutorial you saw that it just glows and dims. Glow and immediately dims. Now you can see the brightness is changing. So now it gradually dims and gradually glows. Now let me change the 255 value to 55 value, and I will change the delay from 10 milliseconds to 100 milliseconds so that you can observe the change properly. So the code is uploaded. Over here, let me change from 255 to 55, and we have changed even over here because when we change the brightness value over here, we need to change over here. If we write 255 brightness, so the values may be different. So Arduino cannot properly understand it and return error. To avoid errors, we are changing from 255 to 55 and gradually don't forget to change even over here. Now let's upload. Now, awesome! The code is uploaded. Now you can see the brightness is very less. Now it gradually decreases and waits for 100 milliseconds. Now before the LED glows more brighter than now. So now you can see it gradually decreases and again glows. Decreases and again glow. So now if you want to customize this and make sure that you need less wires, you can remove the white wire and the red wire and connect the 1 K resistor directly to the ground of the breadboard, which is connected to the ground of Arduino. Hooray! The code is uploaded. We customized our connections and still it's working. This looks beautiful. We saved 2 jumper wires. Thank you for watching this video. If you like this, please share, subscribe and don't forget to hit the bell button to get my latest updates. My name is Suhas. Thank you.